The way your data is stored, or the extent to which you can store it, has tremendous influence on what you can do with it. One important factor is the rate at which data arrives at your computer. Another is the time it takes to store data either in memory or on disk. In case your current computer does not have a hard disk with spinning platters anymore, just imagine you have one of them built in. Disks are organized in blocks, which are the smallest units that the operating system uses to move data between the disk and the main memory. Typically, the Windows operating system uses a block size of 4 kilobytes, and the Linux operating system uses a block size of 8 kilobytes, or multiples thereof. Given a hard disk with spinning platters, not one of those newer solid-state disks, then the disk access takes in the order of 10 milliseconds. Why is this the case? The reading head has to move over to the right cylinder, where the block is stored, and it has to wait for the disk to spin until the correct location is reached. You can assume that this is about 10,000 times slower than direct memory access. This means that if we only want to read a few bytes, then there is enormous benefit in storing the information in the main memory. If these few bytes act as a value destination in a hash table, then the access can take significantly longer than the actual calculation. Of course, you can optimize this to some extent. For example, if we store all data within a single cylinder on a hard disk or across a few neighboring ones, then there's virtually no penalty of moving between different blocks, even when they are on a hard disk. Under ideal conditions, modern hard disks with spinning platters can reach transfer rates of hundreds of megabytes per second. This is good if we want to work with a few megabytes. However, if we need to work with gigabytes of data, then we need to be really clever in the way we deal with it. Not only when it comes to the algorithms we run, but also in the way we store the data on the computer.